Now, look at this. Minutes after becoming man's first ever spacecraft to land on an orbiting comet, and it sends a tweet. How very modern. Touchdown, says the Philae lander, Philae 2014 on Twitter if you want to follow it. My new address is 67p. That's the name of the comet it's landed on. Comet landing is a very useful hashtag if you want to see the whole world reacting to this news. This is the moment that confirmation came through at the European Space Agency.
So we can't be happier than what we are now. We definitely confirmed that the lander is on the surface, and I leave it to Stefan. I think it's up to him to judge how it's going now on the lander.
Okay, so we are there, and Philae is talking to us. First things he told us was that the harpoons have been fired, rewound, and the landing gear has been moved inside, so we are sitting on the surface. Philae is talking to us, more data to come and to be analyzed right now. The flywheel is going down, which it should do, of course. We are there, it's done its job. We are on the Comet.
So all of that was happening in Darmstadt in Germany. Our correspondent Rebecca Morelle is there. I spoke to her a little while ago.
The hard work really begins for this lander. Now it's down on the surface. It's going to begin the science. It's going to be drilling into the surface of the comet, seeing what it's made of. It's going to be sniffing the air, seeing what the gases are made of, looking at the dust, taking a panoramic picture. So the next few hours are really crucial for this probe. I'm joined here by Dr. Matt Taylor, who is the program director of the Rosetta mission. I mean, what does this moment feel like? It's been a long time in the making, hasn't it?
Yeah, it's decades of people's work. Everyone's invested so much time in this, and we're at the top of the mountain now. We've done it. We've landed on a comet. It's never been done before. We're there.
Now, there have been a few slightly worrying tweets about the harpoons maybe not having fired into the surface of the comet. We're waiting to hear more about that, but what could that mean?
Well, we had three mechanisms to secure us on the comet. We had the harpoons, we had the screws, and the thruster system. It appears that we're on the comet's surface. So for me, we've ticked the box. We got on the surface, and we're actually receiving science telemetry from the surface. So although there may be some problems with how we've secured ourselves, we are on the surface, and we're remaining in contact with the lander. So things looking good. We're getting science.
Well, thank you very much. So it looks like the lander is definitely down. That's the crucial thing. That's the thing that's making space history. But really, we're waiting to see how securely is it down. Is it really hunkered down onto the surface of the comet? And that's going to be really important, because as the comet gets closer to the sun, it's going to get incredibly active. All of the dust will start to turn to gas. It's going to turn into sort of a fairly explosive place. So you kind of want that lander to be hunkered down on the surface. But the team here are going to be finding out in the next few hours exactly what's going on. But I mean, this has really made space history today. It's a mission that's been 10 years in the making. It's travelled 6.5 billion kilometres through our solar system, a horrible 7-hour descent and a nerve-wracking wait for the scientists here, but they've done it. They've touched down, and we're actually standing on a comet for the very first time.
And what an achievement that is. Sounds like a hostile environment, though, doesn't it? Now, of course, just getting anything onto an orbiting comet is an achievement in itself, but it's about more than this. This is Chris Hadfield, a retired Canadian astronaut, saying, look, what this is all about is we're now in a position to rewrite what we know about ourselves. Let's look at this in more detail, exactly the work that this lander can do. Now, let's try and explain how this lander and the Rosetta mothership actually reached this comet. We have to go all the way back a decade, 10 years ago, and I've got a graphic here which hopefully can help us understand. The white line is the path of Rosetta, so you'll see this here, this white line, watch out for this, because it's about to get slingshots off various places, including Earth, first of all, in 2005. It then goes on, and Mars becomes involved in 2007. It's using this to build up more and more speed. 2007, a second Earth assist, and then finally, 2009, a third gravity assist. And what is going on? Here is the lander and the Rosetta spacecraft. This is the Comet. It's catching it up. It's getting faster and faster. 18 kilometers a second is the speed that it's traveling. And in the end, you reach the point around August, the last few months, where the Comet was caught up. And then you had to simply get onto it. I say simply, of course, this is very hard. Let's speak to Jonathan Webb, our science reporter. I mean, I was looking at the report around just then, and I was thinking, why did they choose this comet?
Yeah, it was a long decision-making process. They actually originally were targeting a different comet with this particular mission, but then there was a change of plan and they ended up choosing this one, known as 67P for short, for a number of reasons, but mostly because of the path it was taking. They wanted a comet that they would be able to catch up with, and since it's travelling at 55,000 kilometres an hour, that's a big ask, so they had to choose one that they could actually catch with all of those manoeuvres that you described. And then they wanted to be able to stay with it as it approaches the sun, and that's the really interesting thing, because as you saw in a couple of those packages, as it gets closer to the sun, it'll get hotter, all sorts of gases start to be released, and that's what makes comets that familiar shape we see in the sky with the trail behind them. It also means we can find out a lot more about what's inside.
And it presumably means there is a finite period of time when the environment is possible for the Philae lander to operate in.
Yeah, I don't think we actually know exactly what's going to happen as it gets closer and closer and hotter and hotter. But certainly for all throughout next year, even if the lander doesn't stick, even if it falls off overnight and doesn't actually manage to stay on the comet for all that long, the Rosetta ship, which dropped it onto the comet, is going to stay in its orbit and is going to keep it company all the way through next year as it gets closer to the sun and does a loop.
I've got so many questions about this, but one I've been wondering all day is, what's powering it?
The lander itself
Yeah.
actually just got dropped. Once they'd let it go, there was nothing else they could do until it hit the surface of the comet. So there was a lot of tension around that decision to make the final go this morning.
But in terms of the power to send messages back to us over the next few months, where's it?
It has a battery which is powered by solar panels, so I think it can run without solar power for a matter of hours, but it needs to receive sunlight to keep boosting up those batteries.
Very interesting. Jonathan, thank you very much indeed.